Out on the vast expanse of the open sea, a colossal giant dramatically rises from the powerful waves. This is an entire bustling city constructed entirely of steel, purposefully set afloat with a single formidable purpose: to utterly dominate the world's oceans. This is far from any ordinary warship. It stands as the United States Navy's single most advanced aircraft carrier. It is a floating fortress of such immense power that its very presence alone seismically shifts the delicate balance of global power. Every single radar pulse it emits, every low hum resonating from its complex systems declares the same undeniable truth: this ship is truly unstoppable. And today you will comprehensively see precisely why the entire world simply cannot stop talking about it. The world's most advanced warship. When the conversation turns to the biggest and the most overwhelmingly powerful war machines on the entire planet, nothing even comes remotely close to a United States Navy supercarrier. These immense floating giants don't just carry individual planes. They carry the immense weight of entire wars directly on their backs. And right at this moment, the one that stands proudly at the very top is the USS Gerald R. Ford, the newest crown jewel of America's vast naval fleet. This ship isn't just another carrier. It represents the very first in an all-new class that takes everything the old Nimitz class accomplished and powerfully pushes it into a whole new technological era. Think of it accurately as a nuclear-powered city operating at sea, meticulously built to fundamentally change the way carriers will fight for the next half-century. The Ford measures an astounding 1,106 feet long from end to end. That is impressively longer than 3 full American football fields meticulously lined up. The expansive flight deck itself stretches roughly 256 feet across, which is sufficiently wide enough to park a couple of jumbo jets directly wingtip to wingtip with plenty of space to spare. When it is fully loaded, the entire colossal structure tips the scales at an incredible 100,000 tons. But do not think for a single second that its immense size somehow makes it slow. Thanks to 2 powerful nuclear reactors efficiently powering 4 giant shafts, the Ford effortlessly cruises along at well over 30 miles per hour, which is genuinely wild for something of this massive scale. It was constructed in Virginia at the Newport News Shipbuilding Division of Huntington Industries, and it proudly carries the name of President Gerald R. Ford, with the ship sponsor being his daughter, Susan Ford Bales, who officially helped launch it into active service. Now, those 2 nuclear reactors form the real beating heart of the ship. They're specifically called A-1B reactors. And here is the absolutely key thing. They are significantly simpler and cleaner than the old reactors on the Nimitz-class carriers, but they pump out tremendously more raw juice. We're not just talking about propulsion alone. These advanced reactors feed enough plentiful electricity to efficiently run the electromagnetic catapults, the advanced arresting gear, the sophisticated radars, the intricate computer systems, and whatever new high-powered weapons the Navy decides to bolt on in the future. If you climb up to the massive flight deck, one critical detail immediately jumps out: the island, which is the command tower on the right-hand side of the ship, where flight operations and navigation are expertly run. On the Ford, it has been strategically pushed back about 140 feet farther than it sits on a Nimitz, and it has been shifted slightly outboard. It is also noticeably smaller overall. Why was this done? To strategically open up more valuable working space out on the deck. The Navy didn't do this merely for enhanced looks. They did it because more open deck space directly means fewer frustrating traffic jams when planes are actively moving, refueling, and lining up for launch. And on a carrier, traffic jams waste precious time. And time is absolutely everything. Now comes the most exciting and revolutionary upgrade: launching and recovering jets. Completely forget the old steam catapults that violently slammed planes into the air. The advanced Ford uses something brilliantly called EMALS, short for Electromagnetic Aircraft Launch System. Instead of using steam to shoot a heavy piston, EMALS employs linear electric motors to smoothly and powerfully pull the aircraft down the track. The resulting acceleration is far cleaner, The intense stress on the airframe of the aircraft is substantially reduced, and the sophisticated system can be precisely dialed up or down, depending on the specific plane's weight. It does not matter if it is a lightweight drone or a heavy fighter jet. MALS can successfully launch it with the exact calculated push it critically needs. This is straight-up 21st century technology, and what forcefully goes up must inevitably come down. On the Ford, the complex task of landing aircraft is expertly handled by the Advanced Arresting Gear, or AAG. The old, cumbersome water turbine systems are now history. The AAG is a fully digital, power-controlled system that catches incoming aircraft with far greater precision and across a much wider range of sizes and weights. This crucially means the Ford can efficiently recover future drones, lightweight craft, or today's heavy fighters without ever needing separate dedicated setups. MALS and AAG together seamlessly give the Navy a launch and recovery cycle that is significantly smoother, considerably safer, and intelligently built to capably handle whatever the future throws at it. Of course, none of these amazing capabilities matter at all if you cannot move weapons quickly enough to matter. The Ford was ingeniously designed with 11 advanced weapons elevators that do not run on old, unreliable cables or slow hydraulics. These are modern electromagnetic lifts specifically built to haul far heavier loads much faster with considerably fewer sailors needed to operate them. They function like futuristic freight elevators, swiftly bringing bombs and missiles from deep inside the ship's magazines up to the waiting flight deck in record time. The Navy made an enormous deal when all 11 finally came fully online because this was historically one of the hardest features to get perfectly right. But it is utterly crucial because quicker weapons movement directly means planes can get rapidly armed and sent immediately back into the fight faster. The overall deck layout masterfully ties it all together. By strategically shrinking the island and intelligently reorganizing the taxi lanes, the Ford successfully created about 5 whole extra acres of highly usable deck space. That is 5 entire acres where planes can be efficiently staged, refueled, and armed without constantly crossing paths and creating bottlenecks on a busy day. That is the fundamental difference between pure chaos and perfect order. And this smart design leads directly to the single most important metric of all, sortie generation. A sortie is simply one complete aircraft mission. Take off, do the job, and land. The Ford was specifically built to crank out more sorties per day than any carrier before it. Even the large aircraft elevators received a significant upgrade. Instead of the traditional 4, the Ford now has 3, but each one is massively powerful and can lift an astounding 200,000 pounds. That is easily enough to move the very heaviest planes the Navy currently operates. Cutting from 4 elevators down to 3 might initially sound like a downgrade, but with a smarter deck layout, 3 is perfectly plenty. And it logically means less complex hardware to constantly maintain, which is a very big deal when you're trying to keep the ship running smoothly while deployed at sea. Now, let's thoroughly talk about the advanced tech that helps the Ford see and fight. The big one is the Dual Band Radar, or DBR. This is not just one radar. It ingeniously combines 2 different types, an X-band radar for highly precise tracking and multifunction work, and an S-band radar for wide area searches, all seamlessly fused together through one integrated controller. The end result is a crystal clear, comprehensive view of the entire battle space without requiring a chaotic jungle of spinning dishes. That powerful radar directly ties into the ship's electronic brain, the ship's self-defense system, or SSDS. The easiest way to think about SSDS is like a highly automated nervous system. It instantly takes the radar inputs, accurately spots any incoming threats, and automatically directs the right defensive weapons to engage, instead of sailors frantically scrambling through manual steps. SSDS fuses it all together instantly. Detect, track, and engage. When you're facing supersonic missiles, those saved seconds matter immensely. On top of that incredibly capable system, the Ford seamlessly plugs into the wider Navy network with something called Cooperative Engagement Capability, or CEC. This means the Ford does not just see with its own organic eyes. It continuously shares and receives vital sensor data from all other ships and planes in the carrier strike group, like the E-2D Hawkeye, early warning aircraft. Together, they collaboratively build one massive shared real-time picture of the sky and sea. If a hostile missile suddenly pops up from beyond the Ford's own radar horizon, another ship in the group might instantly see it and pass the targeting data along immediately. That is truly next-level teamwork. Now, let's take a walk around the outside and check out the formidable physical defenses bolted right onto the hull. The Ford formidably packs 3 distinct layers of protection. First are the RIM 162 Evolved Sea Sparrow missiles, or ESSM, which effectively cover medium range threats like fast-moving aircraft or incoming missiles. Next in line are the RIM 116 Rolling Airframe Missiles, or RAMs. These are fire-and-forget missiles specifically built to shred low-flying, sea-skimming missiles at very close range. And then there is the last line of defense, the -15 Malawian Quach's Phalanx CIWS, the rapid-fire radar-guided Gatling gun that terrifyingly spits out thousands of rounds per minute. Together, these 3 relentless layers make sure anything dangerous that manages to slip through the outer defenses gets one hell of a fight. But here's where the Ford might impress you the most. It accomplishes all of this with notably fewer people. The old Nimitz class needed a larger crew to keep everything going. The Ford, by contrast, was designed from the very start to sail with several hundred fewer sailors. That is because so many systems that used to be steam-driven or purely manual are now efficiently electric and digitally controlled. The ship is also optimally set up for longer gaps between major overhauls. 12 years between big dockings and a 43-month cycle for regular maintenance. That means substantially less time stuck in shipyards and more valuable time at sea actively doing its job. This monumental shift from steam to primary electric power is genuinely huge. On older carriers, steam did not just drive the ship forward. It also powered the catapults, the arresting gear, and even basic ship services. The Ford brilliantly strips all of that out. By replacing miles of steam pipes with modern electric systems, you dramatically cut down on pipes, valves, persistent leaks, and constant repair jobs. Electricity is far easier to control, much easier to distribute, and way less of a daily headache for the crew. That welcome change leads to significantly better living conditions, too. With fewer hot, cramped steam spaces to babysit, sailors spend less time crawling around sweaty machinery rooms. Modern digital control rooms efficiently replace old watch stations, which means fewer bodies are needed to keep critical systems running. The hangar bay below is thoughtfully laid out with 2 huge open spaces instead of 3 cramped ones, so aircraft can be moved around without requiring constant reshuffling. To the average sailor, all these small changes cumulatively mean less daily frustration and more overall efficiency. When you put all of this groundbreaking technology and smart design together, here is the powerful bottom line. The USS Gerald R. Ford is a 16-feet nuclear-powered electric heavy supercarrier built to launch and recover more planes faster and with considerably fewer people than ever before. It boasts radars that see farther, computers that think faster, defenses that hit harder, and a deck designed to maintain a smooth operational flow under extreme pressure. It costs less to maintain over its full lifetime. It has ample room to grow into the future, and it definitively sets the stage for every Ford-class carrier that will follow. All right, that is enough about what the Ford fundamentally is. Let's dynamically talk about what the Ford actually does and how this supercarrier fights. The Ford is not just a giant piece of steel floating passively in the ocean. What makes it truly scary to potential enemies is how it actually runs when it is out there on real operations. This ship is the centerpiece, but it is not just about the ship itself. What gives it its real formidable power are the planes it carries and the entire strike group that sails protectively with it. If you really want to understand how the Ford fights, you've got to see how the deck runs when it is fully alive, how the squadrons launch in and out like perfect clockwork, and how every single piece fits seamlessly together into one massive coordinated machine. The Air Wing is the sharp sword and the sturdy shield of the Ford. On this mighty ship, you have got F/A 18 Super Hornet squadrons, and they're not just anonymous numbers on a paper roster. They have got famous names you have probably heard before, like the Reagan Bulls, the Black Lions, the Tomcatters, and the Golden Warriors. Then there are the EA-18G Growlers. Those are the specialized electronic attack jets skillfully flown by the Grey Wolves. If you see a distinct plane with a giant radar dish on its back, that is the E-2D Hawkeye, and those highly skilled crews go by the name Bear Aces. The helicopters are the MH-60 or /Chalks flown by squadrons like the Trident and the Spartans. And each version of that versatile helicopter performs a different critical job. And keeping the whole massive operation supplied are the C-2A Greyhounds, reliably flown by the Rawhides, delivering everything from spare engines and critical parts to the all-important mail. That is today's modern carrier air wing. Every single one of those names points to a specific vital job. And when you put them all together, that powerful combination is what makes the Ford so dangerous. The formidable Super Hornets are the main workhorses. They do just about everything. If you need to keep enemy jets far away, they go up on constant combat air patrol with missiles ready. If you need to smash an enemy ship or a hardened base on land, they swiftly swap their loadouts and go in with bombs or powerful anti-ship weapons. They can even effectively act as flying gas stations. They carry what is called a buddy refueling system, which is essentially a hose and drogue pod under the jet that lets one Hornet give fuel to another. That clever trick sounds simple, but it is an absolute game changer. A little extra fuel in the middle of a long mission can be the decisive difference between finishing the job or being forced to turn back. It extends operational range, keeps jets on station longer, and ensures no one runs out of gas at the worst possible time. Right behind them are the potent Growlers. These specialized jets do not carry a full load of bombs like the Super Hornets. Instead, they carry incredibly powerful jamming gear. The Navy officially calls their job electronic attack and suppression of enemy air defenses. Basically, they blind enemy radars, jam communications, and target missile sites on the ground. If a strike package is going into heavily defended airspace, the Growlers are always in the lead. They open the lane, they shut down radars, and they protect the rest of the flight. Without them, the mission risk goes way up. With them, you have a much better chance of getting in, hitting the target, and getting out alive. Then you have got the invaluable Hawkeye, the plane with a giant spinning radar dome on top. That distinctive dome is not for show. Inside, the crew is diligently building the big picture for the entire fight. They scan for threats far out over the horizon, tell who is friendly and who is not, and push vital taskings out to the fighters. The Navy's official label for it is Airborne Early Warning and Command and Control. But in simple words, the Hawkeye is the lookout, the traffic cop, and the group chat for every aircraft in the air. Without the Hawkeye, the air wing would be effectively flying blind. Down low and out on the edges of the formation are the versatile Seahawks, the Romeo version of the MH-60 Hunt submarines and surface ships. It carries dipping sonar, sonoys, torpedoes, and missiles. You will often see Romeos operating from the destroyers and cruisers that guard the Ford. The Sierra version of the Seahawk does everything else. It handles search and rescue, hauls cargo and people, and supports small boat crews. The Navy's own breakdown is perfectly clear.